Our today's topic is gravity and acceleration due to gravity. In this video, we will study gravity, concept of free fall, acceleration due to gravity, value of acceleration due to gravity, and variation in acceleration due to gravity. Let's start with the first one, that is gravity. In the previous lecture, we learned that gravitation is the phenomenon of attraction between any two bodies in the universe. If we replace one body with Earth, then this becomes a special case of gravitation, and this special case is named as gravity. Hence, gravity is the phenomenon of attraction between Earth and any object in the universe. And the force of attraction between Earth and any object in the universe is called force of gravity. From the universal law of gravitation, we know gravitational force between two bodies separated by distance r is given by this formula. If we replace one body by Earth and denote its mass by capital M and mass of body by m, and they are separated by the distance r, then force of gravity is given by this formula. Here r is the distance from the center of Earth to the center of object. If you drop an object from certain height, the object will fall down towards the center of Earth because Earth attracts every object towards its center. Remember, we are not pushing the object, we are just dropping it from certain height without applying any force. If we neglect all the forces acting on it and consider only the force of gravity, then we say object is in free fall. So we can say all the objects falling towards the center of Earth under the action of force of gravity alone are said to be in free fall. If an object is moving with uniform velocity in a straight line, then we said there is no acceleration in an object because there is no change in velocity. Now, if we push the object continuously with some unbalanced force, then there will be change in velocity, which implies there is acceleration in the object. Similarly, when we drop an object from certain height, the Earth is exerting continuously the force of gravity on it. So when there is unbalanced force of gravity continuously acting on an object, this implies the object is under the acceleration, and this acceleration is called as acceleration due to gravity. So acceleration produced in a body in free fall due to gravitational force of Earth on the object is called as acceleration due to gravity. It is denoted by letter G. According to the Newton's law of gravitation, force of gravity on any object at a distance r from the center of Earth is given by this formula. But we know when an object is in free fall, it falls with an acceleration which is acceleration due to gravity. But according to Newton's second law of motion, force is a product of mass and acceleration. Therefore, in this case, force of gravity is equal to the product of mass and acceleration due to gravity of that object. That is, F is equal to mass times acceleration due to gravity. Combining the two, we get this equation. And solving for g, we get acceleration due to gravity is equal to gravitational constant times mass of earth divided by r square. This is the relation between acceleration due to gravity and universal constant of gravitation. Remember, the distance r in this formula is the distance from the center of earth to the center of object. If an object is on the surface of earth, then the distance r in the above equation is replaced by the radius of earth. Thus, for an object on the surface of an earth, acceleration due to gravity is given by this formula. We know that on the surface of earth, acceleration due to gravity is given by this formula. All the letters on the right side of above equation are constants and their values are given as gravitational constant g is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Mass of earth is 6 into 10 to the power 24 kilograms and radius of earth is 6.4 into 10 to the power 6 meters. On substituting these values on above equation, we get the value of acceleration due to gravity as 9.8 meter per second square. In the equation given as this, there is no involvement of mass of object. So we can say acceleration due to gravity does not depend on mass of object. In other words, all the objects of any mass fall with same acceleration towards the earth, provided no other force is acting on it. We know acceleration due to gravity on the surface of earth is given by this formula. Its clear value of g depends on gravitational constant, mass of earth and radius of earth. Since gravitational constant and mass of earth are constants, but the radius of earth varies because earth is not perfect sphere. Also, the distance from the center of earth to the center of object may vary. Hence, there may be some change in value of acceleration due to gravity. Let us try to find it. As we know, earth is flat at poles and bulged out at equator. So polar radius is minimum and equatorial radius is maximum. Also we know acceleration due to gravity depends inversely on the distance. Therefore, acceleration due to gravity at poles will be maximum because polar radius is minimum. Similarly, acceleration due to gravity at equator will be minimum because equatorial radius is maximum. As we move above the surface of earth, the distance from the center of earth increases. But we know acceleration due to gravity depends inversely on the distance. So value of g decreases with increasing distance from the center of earth. Or we can say value of acceleration due to gravity decreases with increase in height above the earth. This was all about gravity and acceleration due to gravity.